Let's take a look now at how the actual settings are made on this machine. All of the controls on this machine are done with push buttons. The main power switch for this machine is on the back, and once it's switched on, you can see the display on the front. The first switch we'll look at is polarity. This is where we switch between alternating current, such as we'd use for welding aluminum, and direct current, which we'd use for most everything else. The next switch is for the process. For all of the TIG welding I do, I use the top setting, the TIG high frequency impulse setting. What this means is that the arc will start if we just get the electrode close to the metal and push down on the foot pedal. That means we don't need to touch the electrode to the base metal, which could possibly contaminate it. There is a setting for lift arc, which means you would touch the electrode, but I don't recommend using that for TIG welding. And there is a setting for stick welding. Actually, this makes a very good power source for stick welding. The next button is the output control. This might be used if you ever weld without a variable hand or foot control. Mostly I keep this disabled in the standard position. The next button we'll look at is for the pulse portion of the circuitry. What this does is it sets a lower limit and an upper limit for the current, and then when you're welding, the current cycles automatically between the limits that you set. This does have some applications for certain types of welding. The next button is for sequence. Again, if you're using a foot or hand control, this is disabled. The next button is used to set pre-flow and post-flow. Now, pre-flow I'm going to do in a manual manner, so we don't need to use the automatic setting for pre-flow. Post-flow is different. What we're setting with post-flow is the amount of time that gas continues to flow over the electrode, shielding it as it cools down after the welding current has stopped. Without any post-flow, the electrode oxidizes immediately, and then the next time you weld, the oxides break off the electrode and they contaminate the weld pool. This is very bad. So we need to have enough post-flow to shield that glowing red electrode until it cools enough that it won't oxidize. A pretty good rule of thumb for this is that we need about 1 second of post-flow for every 10 amps of welding current. So if we're welding at 100 amps, we want at least 10 seconds of post-flow. The button on the right is the one that controls the AC waveform. This is the control we have that balances cleaning versus penetration. And in the other mode, we can change the frequency of the waveform. The older sine wave welders always had a 60 cycle per second waveform. With this machine, we can control all the way from 30 cycles per second to 250 cycles per second, and the higher frequencies develop more penetration. Probably the most important control we have is the amperage of the welding current. We can set it from a low of 5 amps all the way up to 200 amps. The more amperage, the more heat. And this window shows the output voltage. You won't see anything in this window until we're actually welding. TIG welding relies on the use of an inert gas for shielding the weld area. In most cases, we use argon gas, and that's what's in this cylinder. For certain specialized situations in industry, helium gas can be used, or sometimes an argon-helium blend. That promotes greater penetration in thick aluminum plate, but for everyday use, argon is what we'll use. There's a high-pressure bottle with the argon in it, and there's a valve on the bottle that needs to be opened. You need to use care when opening this valve. You should open it very slowly so the gas doesn't rush in against the diaphragms in the flow meter. And then it's opened until it seats against the top seal. If you only open this a small amount, it can leak gas out around the stem. And once you bought a couple of bottles of argon, you'll appreciate just how expensive the gas is. And then the pressure is set by turning this adjustment on the flow meter. And for most welding, we want between 15 and 20 cubic feet per hour. You must be very careful when handling these bottles. If the bottle accidentally gets knocked over, or if the stem is broken, this bottle will take off like a rocket. So here's a simulation of what would happen if the neck gets broken on a bottle. Not a pretty picture. There's a few more components of the machine I want to talk about. This is the foot pedal that I normally use to start the machine and then control the heat as I'm welding. So when there's no pressure, there's no current flowing. And when I just press this down a little bit, it starts the current flowing, but at a very low amperage. And then as I press the pedal down farther and farther, it builds the heat up as much as I want to or need to. Very nice to have that kind of control. And I use this foot control for most of the welding I do. Occasionally, for out-of-position welding, it's not convenient for me to use a foot pedal. Imagine if I'm laying on my back or working on a ladder. So in situations like that, there's an optional heat control that goes right on the TIG torch. So this has a small thumb wheel that can be turned, and this does exactly the same thing as what the foot pedal does. When it's rotated one direction, the machine is switched off. Rotating it the other direction just a tiny bit switches the current on, but at a low amperage. And then the more I rotate this, the more it builds up the heat at the weld. And then I can switch it off immediately. Very nice to have that as an optional control. And of course, anytime that I'm doing welding, the workpiece needs to be electrically grounded. And that's normally done with a clamp like this that connects directly to the machine.